Okay, so I will try my best to finish my presentation within 15 minutes. Okay, I can see. Okay, so yeah, today I want to talk about our recent research about how can we use the programmable switches to enable some new security applications, new security systems. So yeah, my title is about fast and scalable in-network security. So with the program switches. So I just want to give a brief introduction about our recent works in this area. So we have recently we have developed a couple systems. So here I want to emphasize 3 systems we have developed. The first system we call IMAP. So yeah, these systems we try to achieve fast and scalable in-network scanner. So with the program switches. So we have paper published in the Hotlines even last year. And this year we have presented a lot of paper, just a long version papers in the ASDI. The second system we developed, we call Poseidon. So yeah, in this system, so we can achieve, actually we try to use this system to minimize, even large scale DDoS attacks. So based on program switches. So we have this paper published in the NDSS, 2020. So the third system, so we call fast FE. So yeah, we want to use this system to accelerate so machine learning based traffic analysis. So using the program switches. So we have this paper published in the SICOM workshop they call SPY. So 2020, and we have prepared a lot of paper. So I will extend this. Actually extend this system, and we develop a new system. We have papers or just under submission. So for next year. So let's see. So I just give a brief introduction. So maybe I can focus on the first system, and I will briefly discuss the second and third system. For the first system, so we developed. So we mainly focus on network scanning. So yeah, we know. So network scanning actually is very important. Even process. So to protect the security of our networks. So we can use network scanning to discover some new vulnerabilities. In our networks. Also, we can detect some maybe vulnerable hosts. Even we can monitor the host services deployed in our networks. So yeah, this is very important. So systems we have been widely used by system administrators, these network administrators. But actually, we have some new requirements for network scanner. So especially, so right now, we try to deploy IPv6. So yeah, because IPv6, we have a large scanning space. So compared with the IPv4, very full. A lot of motivations for why we need new scanners, because right now we have so many IoT devices. So they are connected with each other. So let me they make our existing networks more complicated compared with the traditional, even previous networks. So this is why actually we need the network scanner should be very fast. So because we have large scanner space, also should be scalable. So because we have so many different devices. But the problem so for current existing network scanner, actually they are just implement. We see in the server. So we have IMAP, we have MMAP and ZMAP, even must scan. So actually those existing scanner just we implement, we just run them. We implement it as a software. We run them just on a server. So that means we use a CPU to run those scanner. But the CPU actually is very slow to process those packets. And also we just deploy those scanner in the server. So that means the scanner can generate traffic. Those traffic will go to the edge, go to the different edge, and then so this will cause the bandwidth delay. Even we have limited bandwidth, and a lot of problems. So if we deploy those scanners or within the server, we put a server in the in the edge. So actually those traffic, the general scanner traffic will go through the whole networks. So if they want to scan other servers. Actually they may have a long scan path. So this is some existing limitations for traditional software-based network scanner. So the idea is for our system, our IMAP, so we try to build we call in-network scanner. So the major idea is, okay, so we actually try to deploy our scanner within the switch, especially we use a program switch we discussed. And the switch can process, okay, actually the package very fast. And we try to, because we deploy the scanner within the switch, so in this case, we can do the in-network scanner. That means even the scanning path should be short, can then progressively use the server to do a scanner. So this is the best idea. So if you want to do the in-network scanner, so actually, so yeah, we found actually the program switch should be a good place, yeah, a good tool for us to build, okay, this kind of scanner. So because the program switches can achieve very high packet processing capacity, even they're very flexible to deploy, okay, to support a different scanner, okay, scanning task, because we can program, we can reconfigure those switches, okay, very easily. Also, especially we can do very large, okay, actually the large scanner, so that means the performance should be very fast. So this is something. So our idea, we just use the program switch to build a fast and scalable, okay, in-network scanner. So this is a new type of scanner. So we call IMAP. So yeah, this is the design about IMAP. So because I don't want to spend too much time to discuss details about the IMAP, but yeah, I think the major idea, so we have we can provide a control program, even interface. We have a new language, and anybody can use this language to design the new scanner tasks. And then so those kind of scanner tasks can be, okay, those functions can be configured within the program switches, and we can use program switches to do this, to generate a scanner package, and we can scan a large IP event space. So this is the basic idea. So if you are interested, you can take a look at our paper. So actually, yeah, we have some preliminary evaluation result. We use actually Porphyro. So the switch, program switch, and then we deploy, okay, this kind of scanner. So actually, this is the collaborative work with the Tsinghua University. They have deployed in the campus network. They can achieve, okay, a 40 gigabyte, okay, per second, even the scanner. So yeah, this is some preliminary evaluation. They can achieve very high throughput, about 40 gigabyte throughput. So compared to traditional even the JMAC can only achieve about 10 gigabyte. Also, this kind of scanner actually we put in the switches. So the overhead for switches actually very low. So yeah, we have done some very comprehensive evaluation about the overhead of the scanner. So yeah, this is the first tool. So we just use the program switches. We build a new generation scanner, and we can achieve very fast and even high performance, okay, scanning. So this can to support, okay, to identify those vulnerable devices, even IoT devices, even we can scan large IP spaces. Okay, the second tool we have built, so mainly focus on DDoS, okay, defense. So because right now our current existing DDoS defense system, so we put in the data center, and then we implement, okay, those DDoS defense system. We use mid boxes, but mid boxes actually based on hardware. So those defenses can achieve high performance, but the problems are actually they are very expensive because we should purchase the hardware. Also, they are not, okay, flexible. So because the hardware is hard to change and the configuration in this hardware. Another idea, so to build a DDoS defense, we can use the NFV, another function virtualization. That means we can build virtualized, okay, the functions we can put in the virtual machine. But okay, yeah, NFV can achieve flexibility. So also we can elasticity. We can easily establish a new instance for NFV functions. But the problem actually the NFV, because it's based on software, so is the performance is very low. So yeah, our goal, so because we can see the mid boxes, okay, solution, even NFV solution actually have some benefit, okay, they provide also have limitations. So in our goal, so for the precedence, so we try to build, okay, programs, even DDoS defense, okay, the system, so especially based on the program switches. So because based on program switches, we can achieve both even even high performance. Also, the cost also is very low. Also, we can achieve flexibility. So yeah, this is the design for the precedent. So we also design a new policy. So I mean, anybody can use our policy to design the new functions about DDoS defense. And then so those kind of policy can be we have compiler can be compiled with to the program switches. And then so we can use the program switches to do this kind of the DDoS defense functions. We have some models of DDoS defense functions with the switches. So let's see. So we have done we have built a system, and we have done some the evaluation. So we can see the first evaluation. So this diagram just shows. So we can see in the throughput. So using our without we can see this is the original attack. So we can see to the we use the UDP package to do DDoS attack. We can see that actually this kind of attack actually can about a couple of seconds. So, but if we use our program switches, actually we can defend this attack in a very short time. So we can make this the red one is the just normal traffic, and the blue one is the attack traffic. So we can see use our program precedent system. Yeah, we can do the defense very quickly. Also, we can see in the overhead. So the latency about using the precedent. So we compare precedent with the middle box based the DDoS defense. So it's a hardware based DDoS defense system. Also about Bahati is a NFV based solution. So we can see actually precedent can achieve very low end-to-end defense latency compared with the hardware based defense system, even the NFV based DDoS system. So that means precedent actually can mitigate DDoS attacks very effectively. So we can also efficiently. So this we have done something. This precedent system. So we can also use the program switches to help us to do DDoS defense. Okay, the third system I want to discuss a little bit about this is about we call machine learning based network security application. So we want to also use the program switch to accelerate this kind of application. So we can see right now deep learning, even machine learning, especially deep learning, has been widely used for different security applications. We have bot detection, website fingerprint, even a cold channel detection, intrusion detection. But we know machine learning actually, especially deep learning, actually is very expensive. So performance is very low. So this is why actually the scalability actually is a big problem. So if you consider about the kind of deep learning based security applications, so actually we can see the bottleneck. Actually the major bottleneck should be normally they have two components for those systems. One they call feature extractor. Another one they could behavior detector. But we found actually the major bottleneck is about feature detection, detector. So we have something the preliminary evaluation. So we can see there are two components, feature extractor and the behavior detector. We use QSULI. QSULI is the deep learning based intrusion detection system, and we can see the feature detection actually has caused a major overhead for the system. So this may cause scalability issue. So based on this kind of observation, so we build a system we call fast FE. We call fast feature extraction. So the major idea, so the same thing. So we try to use the program switches to just we try to put on the feature value extraction function we see in the program switches, and then we can accelerate this kind of feature extraction. So we can still we design a policy with new policy. We have policy interfaces, and then so anybody can use our policy engine to design new applications. Based on if you want to process the features for your application, you can use our policy, and then you can design. We have a policy enforcement engine. We can transfer policy, high-level policy into the underline the primitives, and then we can enforce those feature extraction functions within the program switches. So this is the basic idea. Actually, more details about design. So actually, you can take a look at our paper. Actually, we have published papers or in a spine. So yeah, this is a workshop paper, and we have prepared a new paper. So we submit to SDI. So in that paper, actually in that paper, we try to use both program switches and also the smart link. The smart link, yeah, they can they can work together to accelerate the feature extraction for those AI-based, especially deep learning-based traffic analysis. So for security purpose. So yeah, this is about the evaluation result. So we can see, but the summary is we compare our system with the system without the faster FE. So we can see the coin similarity numbers we can achieve. Okay, the very similar. Okay, the performance. Yeah, it's about accuracy. The performance. And also about scalability, we can see because this is a major goal we want to achieve. So we can see, we can measure the systems with the K3 is the intelligent deep learning-based IDS. So about native, the K3 we can see actually the bandwidth, actually the server bandwidth, normally if the traffic rate increase, the server bandwidth will be, we can say the overhead can increase a lot. But using a fast FE with K3, actually we can see the performance actually can be and the overhead can be reduced a lot. So this this one evaluation. Another evaluation we try to see the CPU utilization rate. Even we can because they are traditional system actually they are actually the CPU utilization rate is very high. But if we use our fast FE solution, actually the CPU we can reduce CPU overhead a lot as well. Okay, I think that's all about we just discussed the 3 systems. We use the program switches to achieve even especially for security purpose. So